All right, we're back. We are still on page something, page 4 of notes 8 of Calc AB, doing L'Hopital's rule when necessary. We're trying to do the correct work that'll get us all the points that we can possibly get when we take the AP exam. So let's keep going. So we are on J. Why are we on J? Oh, look, I labeled them across pages. That's unusual for me. It's actually pretty unusual for me to like label any problem. I usually just write problem and then do it. All right, so I feel like this is going to be a multiple application problem because of that x squared in the denominator. Like it's going to go x squared and then 2x and then 2. So I think I'm going to have to do multiple applications, but you never know. All right, so cosine of 0 is 1. So it's 1 minus 1 in the numerator, 0 in the denominator. So yeah, they're both 0. So let's do this. The limit. Oh, let's should I use blue? I don't want to. Kind of like using black as my like default color. Limit as x approaches 0 of cosine of mx minus cosine of nx is equal to the limit as x approaches 0 of x squared, and those are both 0. Okay. Therefore, I'm just trying to squeeze things in here. Therefore, by L'Hopital's rule, the limit as x approaches 0 of cosine of mx minus cosine of nx over x squared equals, all right, what does it equal? The limit, am I going to make it? I don't think I'm going to fit this. All right, we're going to go down a level. Equals the limit as x approaches 0 of the derivative of cosine of mx is going to be negative m sine of mx, and then it'll be plus n sine of nx, and then divided by 2x. Okay, and then obviously sine of 0 is 0, so we're going again. So the limit, but I think we'll be done on this one. Limit as x approaches 0 of negative m times sine of mx plus n times sine of nx. I wonder if I'll even be able to check this on the calculator because there's a lot of variables here. 0 of 2x equals 0. Therefore, by L'Hopital's rule, gosh, the limit, can I just, are you gonna be mad at me if I just copy and paste? I feel like you will be, because that means that you have to like handwrite it and rush to keep up. We could like name this like Q or something, or like capital L for limit and just say like L is equal to, but we didn't. So this limit is equal to, I'm gonna bleed into the next one, equal to the limit, well, maybe not, as x approaches 0. All right, what are our derivatives? The derivative of sine of mx is m times cosine of mx, but there's already a negative m, so negative m squared cosine of mx. The derivative of sine of nx is n times cosine of nx, but there's already an n, so it's going to be plus n squared cosine of nx, and then all over 2, which is our saving grace, because we know we're getting an answer this time, because we're not going to get an indeterminate form because the limit of the denominator is 2. It's not 0. It's not infinity. We're getting an answer. All right, cosine of 0 is 1. So actually, we just get n squared minus m squared over 2. All right, that's nuts. That's so crazy that I'm going to highlight that. This limit is just that. That's sort of unbelievable. I'm going to do the other problems and then go back to the calculator and see if I can like get it to give me that answer, which it might just give me directly. That would be nice of it. But it also may not. That would be less nice of it. All right, let's see. If you plug 0 in the numerator, you get 0 plus 0, you get 0. Plug 0 in the denominator, you get 0 plus cosine of 0 is 1. So this is actually 0 over 1. This is 0 and we're done. Yes, finally. Finally, it pays off that we're trying to evaluate these by direct substitution. That's 0, and we get to move on, which is awesome, because this one is not 0, and I don't know how complicated it'll be. So the limit, definitely the limit as x approaches 0 of x is clearly 0. The inverse tangent is a super useful graph to know. So actually, I'm going to put it over here. I'll put it over here in a different color, so it's like, I don't know that it'll ever be obvious that it's not a part of that previous problem. This is your arctan graph, right? This pi over 2, negative pi over 2. You should be reviewing that all the time. You get asked the limit as x approaches infinity of arctan frequently for some reason when you take Calc 2. So make sure you're aware of that. But anyway, the arctan of 0 is 0. What? I forgot a limit. Dang it. So much writing. Okay. The limit as x approaches 0 of tan inverse of 4x is equal to 0. Therefore, by L'Hopital's rule, kind of excited. We're like nearing the end of a page. I was worried that I start like speeding up because I just want to like get it done. But I don't know. I bet some of you think I go too fast no matter what I'm doing. And some of you are probably listening to this on 2x speed because you can't please anybody. All right, L'Hopital's rule. Limit as x approaches 0. The derivative at the top is actually 1. So that's sort of encouraging. What is the derivative of arctan? So the derivative of arctan is arctan of x is 1 over 1 plus x squared. So this is going to be arctan of u is 1 over 1 plus u squared times the derivative of u. So it's going to be, how should I write that? I mean, I'm just going to write it. It's 4 over 1 plus 16x squared. Okay, why is it that? It's 1 over 1 plus u squared, so u is equal to 4x. So 1 over 1 plus 16x squared times the derivative of u. The derivative of 4x is 4, so it becomes 4 over. You should take a lot of derivatives of arctan. Arctan comes up like more than you would ever have guessed when you first learned trig. It's like the most important trig functions, this isn't true, but like sine, cosine, arctan. Those are like the most common things that you end up using, I think. All right, so if x is 0, then our denominator becomes 4 over 1, which is 4. So I believe the answer to this question is just 1/4. And I think that's done. All right, so let's try to get the calculator to give us these answers. I'm confident that K will be easy on the calculator. So switching over. If you're done with this video, you are done. Get out of here. If you're interested in this kind of thing, let's see what we can do. So we want the limit of cosine of m times x. So it's mandatory that you put multiplication there, or it will think that mx is its own, like here. It thinks nx is a variable, not n times x. If I do this, now it knows it's n times x over x squared. So I'm not sure this is going to give me an answer, but what I could do, well, maybe it will give me an answer and I don't even need to worry about it. Oh, excellent. So that's what we got. You can do com denom. You really only mess around like this if you're actually typing. That's awesome. It just spits out the answer. I thought I was going to have to do all kinds of weird. So my plan was going to be, if it didn't give me the answer, I was going to substitute numbers, like substitute 3 and 5, right? And I get 8. And I know that I'm expecting to get n squared minus m squared over 2. And then I had just set n equal, so I made m, according to the problem, I made m equal 3 and n equal 5. So that was my plan. I was just going to plug in numbers and see if it like gave equivalent things, but I didn't need to because it worked. So that was great. I was hoping that would happen, but I was, hope for the best. Hope for the best, expect the worst. That doesn't seem right. Hope for the best and I don't know, be okay with the worst, like if it happens. 0, we were expecting that. I think it's hope for the best and expect the worst, but like, why do you that's no way to go through life. Comma x, comma 0, 1/4. Nailed it, we got all of them. All right, so this is it. Like, we are doing good quality work on these, even when it's a lot of work that we don't necessarily want to do. We're still getting it done. So here they are. Let me scroll up so you can grab your screenshot of that, grab your screenshot of this, and then I'm going to end this video here. I'll be back in the next one to do a little bit more of these notes, and I will see you then.